Hello viewers, this is Mr. David. I would like us to go through chemistry paper 2C of June 2019. It's quite unfortunate that the marking scheme and the examiner report of this series is not yet out. It would have helped us to understand better what the examiner required or what sort of answers they required you to write as a student. But that is not a problem. We are going to go through it and maybe try our best to work out the answers that the examiner would have required you to write down in all the questions. If you have any question at the end of it, kindly please write it down in the comment section below. And I also ask you to subscribe and share this video so that anytime I upload another one, you will be notified, and also it can help other students also. So let us start from question 1 of the paper. Question 1 of the paper is about atomic structure. It says that the diagram shows the particles in an atom of an element. So an atom of an element is made of particles. Those particles are known as subatomic particles. And an atom of an element has got two parts. It has got a nucleus. So this is the nucleus. That forms what we call the nucleus. And inside the nucleus, we have got protons and neutrons. And an atom also has got what we call the energy shells or energy levels. So we have the energy shells or the energy levels. So inside the nucleus, we have got protons and neutrons, but inside the energy shells, we have got what we call electrons. So protons and neutrons are found in the nucleus. Protons are positively charged, neutrons do not have a charge. They both have a mass of 1. Electrons are found in the energy shells. They are negatively charged and they are the smallest. They have a mass of around 1 over 1836. We can round off to 1 over 1840. Now, the first question says, the box gives the names of some particles. So you are given electron, ion, molecule, neutron, and proton. And then you are told, use words from the box to label the diagram. So use words from the box to label the diagram. So the first box is going to a particle which is positively charged and it is in the nucleus. That particle now is proton. The second one goes to this particle in the energy shell and it is negatively charged. So that particle is electron. The third one goes to the particle which is inside the nucleus but does not have a charge. Therefore, that particle is known as what? Neutron. I hope that is clearly understood. Question B, give the mass number of this atom. That brings us to a new thing. What is mass number? So mass number is equals to protons plus neutrons. Mass number counts everything which is inside the nucleus. Mass number is also called nucleon number. So you count everything which is found inside the nucleus. Now, here you go and count the number of protons, the positively charged one. That is 1, 2, 3, 4, 5, and 6. So protons are 6. You add to the neutrons. Neutrons are 1, 2, 3, 4, 5, 6, 7. Neutrons are 7. Therefore, the mass number becomes 13. Therefore, the mass number is 13. Then complete the sentence about isotopes. They want you to mention what isotopes are. So isotopes are atoms of the same element. Isotopes are atoms of the same element with different masses. The reason why they have different masses is because the number of neutrons in them is different. So isotopes are atoms that have got the same number of protons. They have got same number of protons. So protons are the same, but different numbers of neutrons. They have different numbers of neutrons. So that is all about question number 1, and that is going to earn you 6 marks. Let us go to the second question. The second question talks about a table that is giving information about halogens. So that also brings us to a new thing. What are halogens? Halogens are atoms or elements in group 7. These are atoms or elements in group 7. So they are atoms in group 7 of the periodic table, or elements in group 7 of the periodic table. Now, we have been given the name of the halogen, the physical state at room temperature, and the color. They say that chlorine is a gas, which is pale green. Before chlorine, we can have another one, which is known as what? Fluorine. Fluorine is also a gas, and it is yellow. That is the color of fluorine. Fluorine is yellow. It's the first member of the group of halogens. So the second one is chlorine, which is a gas, and it's pale green. So fluorine and chlorine are gases. Bromine, at room temperature and pressure, bromine is a liquid, and it is red-brown, but it can vaporize. It can form vapor, and form a vapor which is orange-brown. Iodine is a solid. Iodine is a solid, and the color of iodine is gray. Or you can say gray-black, it will still be accepted. But it can also form a vapor, and the vapor will be purple. The vapor will be purple. So I've said this one can form a vapor which is orange-brown or orange-red. And this one can form a vapor, iodine can form a vapor, which is what? Which is purple. A vapor which is purple. So we have completed the table. The second one says, chlorine has two isotopes of mass number 35 and 37. They are isotopes of chlorine. Why? Because they are having the same atomic number, but different mass numbers. So the mass numbers are 35 and 37, but the atomic number of chlorine is 17. So the relative percentage of these isotopes in a sample of chlorine is, chlorine 35 is 77.8, chlorine 37 is 22.22. Calculate the relative atomic mass of this sample of chlorine, give your answer to 1 decimal place. So it's about how you arrange the calculation. It is on how you arrange the calculation. So first of all, we say we are given 35 times 77.8. You get the mass of those ones with the total mass of those ones with a mass of 35. And then you get those ones of 37 times 22.22. Then you are supposed to divide everything by 100. After that, get the answer to that one and then write the relative atomic mass. But remember to write the relative atomic mass to 1 decimal place. Remember to work it out and write the relative atomic mass to 1 decimal place. I don't have a calculator with me. You can calculate that one and get the answer easily. The next one. A student is given an aqueous solution of chlorine and aqueous solution of potassium bromide. Explain how he can use these two solutions to compare the reactivity of chlorine with the reactivity of bromine. That is known as a displacement reaction of group 7 elements. The reactivity of group 7 elements decreases down the group, which means as you go down the group, the most reactive one is fluorine, followed by chlorine, bromine, and then iodine, and the last one is astatine. So reactivity decreases down the group. So they want you to note how you can use these two solutions to compare the reactivity of chlorine and bromine. So what you do, number one, mix the two solutions. So what I will do, number one, is I will mix the two solutions. Which solutions? Solution of chlorine and solution of potassium bromide. So mix the two solutions, that is solution of chlorine and solution of potassium bromide. That okay? Then we can say the solution turns orange. The solution turns orange. Why? The solution is turning orange because bromine is produced, or we can say bromine is what? Is formed. Bromine is produced. So this one shows that chlorine is more reactive. Chlorine is more reactive than bromine. That is the reason why chlorine is displacing what? Chlorine is displacing bromine. That is why chlorine is displacing bromine. The next question. The next question says that methanol, ethanol, propanol, and butanol are alcohols. You know alcohols. Alcohols are compounds formed by two ways, either fermentation or hydration of what? Of alkenes. Then we say, so we do fermentation of things like glucose using enzymes, and then we can also do what we call hydration. But next we say, a student uses this apparatus to compare the time taken for the four liquids to evaporate. So we have the alcohol, and then we have got the water. We cannot heat the alcohol direct, so we use something like a hot water bath, because alcohol has got a low boiling point. So what happens here is that this water is hot, and the water is going to release water vapor, which has got a high temperature. That is going to allow the alcohol to do what? To evaporate. So it's going to release vapor, which is going to heat the alcohol and allow it to evaporate. So she uses this method. Pour some methanol into evaporating basin. The methanol is the alcohol there. Place the evaporating basin on top of a beaker containing hot water. Measure the time taken for the methanol to evaporate completely. Repeat the experiment with each of the other alcohols using the same apparatus. State two variables the student should control to make sure our results are valid. Number one, we have alcohol here. Number two, we have got water here. These are the two things that we are using. If any variables are being changed, then the variable should either be affecting alcohol or either affecting water. Number one, we should make sure that the volume of alcohol is the same. The volume of alcohol we are using should be the same. That is going to ensure that our results become what? Valid. Number two, the temperature of water. Not necessarily the volume. The volume of water does not matter, but the temperature of water. The temperature of water is going to affect the alcohol being evaporated. So those are two variables that you are going to do what? To check on. So the volume of alcohol and the temperature of water. State why it is not safe to heat the evaporating basin directly with Bunsen flame. Why should you not just heat it directly with a Bunsen flame? Why? Because alcohol is flammable. The alcohol is flammable and can easily catch fire. Alcohol is flammable and can easily catch fire. The alcohol is flammable and can easily catch fire. So heating it using a hot water bath is a safety precaution. That is a safety precaution. Next question, still on those alcohols. They say the table shows the results of the experiments done by 4 students. So the experiment tends to be valid because it was repeated. So they say we have got methanol, we have got ethanol, we have got propanol, and we have got butanol. So we have got student A doing the experiment, student B doing the experiment, student C doing the experiment, and then student D. And then they work what we call the mean time taken for the alcohol to do what? To evaporate. So you know how to do the mean time. You take the anomalous, you take the concordant results, you add them together, and then you divide. But you always know that we must discard or we must remove anomalous results. So the first question says, calculate the mean or the average time for butanol to evaporate. Calculate the mean for butanol to evaporate. Butanol is the first one. So we have got 64, 63, 90, and 60. 64, 63, and 60 are concordant results. They are near each other. 90 is far away. So we are going to consider this 90 as an anomalous result, meaning that when we are working out the average, we are going to do away with it. We can't use it. So to calculate the average, we are going to have 64 plus 63 plus 60. Then we are going to divide by what? We are going to divide by 3. So that is going to be something like 187 divided by 3. So that is going to be 6, 62. That is going to be something like 62 remainder what? 62.2. It's going to be something like 62.2. Explain how the results show which alcohol evaporates easily. How does the results show which alcohol evaporates easily? If it is going to evaporate easily, the easily there now tends to bind with time, the time taken. So this one's going to take 48. This one you said is going to take 62.2 as the mean time. This one is 33 and this one is 23. So the one which is taking less time or shortest time is what? Is the one with 23. So explain which of the alcohol. First of all, answer the question which. Which is methanol. Then give an explanation for you to get what? For you to get the 2 marks. Say that it takes the shortest time to evaporate. It takes the shortest time to evaporate. State the relationship between the number of carbon atoms in the molecule and how easily the alcohol evaporates. The number of carbon atoms. You can see we move from methanol. We go to ethanol. We go to propanol. We go to butanol. From there, we can check the number of carbon atoms. As we go down, the number of carbon atoms are what? Are increasing. And as the number of carbon atoms are increasing, the mean time taken is also what? Is also increasing. Meaning, the less the number of carbon atoms, the easier the alcohol does what? Evaporates. But when the carbon atoms are more, the alcohol takes more times to do what? To evaporate. So I can say that as the number of carbon atoms, increases, the number of carbon atoms increases, the alcohol takes more time to do what? To evaporate. As the number of carbon atoms increases, the alcohol takes more times to do what? To evaporate. Or we can say the alcohol becomes what? Less volatile. You know what volatility is. Volatility is the ability of a liquid to do what? To evaporate. So as the number of carbon atoms increases, the alcohol takes more times to evaporate, or the alcohol becomes less volatile. The ones which are more volatile, they take less time. The ones which are less volatile, the ones which are more volatile takes less time. And the ones which are less volatile takes more time. Then number 4. Number 4 says, this question is about metals. Which statement describes metallic bond? A metal. How do we know that a substance is a metal? How do we know that something is a metal? Something is a metal. If you melt it, then it can do what? It can conduct electricity. A metal must be able to conduct electricity. Then, metals, the structure. A metal has got what we call a regular lattice. It has got a regular arrangement of particles. The particles which are found in a metal are positive ions and the negative delocalized electrons. So the attraction between the positive ions and the negative delocalized electrons, that is what holds the metal together, and that is what we call metallic bond. So which statement describes metallic bond? Electrostatic attraction. Electrostatic means something is positive and another one is positive. Electrostatic attraction between oppositely charged ions. Wrong. That one is about what? Ionic bond. Electrostatic attraction between the nuclei of two atoms and a pair of electrons which are electrons shared between them. Wrong. That one is covalent bond. Electrostatic attraction between positively charged particles and delocalized electrons. Electrostatic attraction between atoms. Atoms does not have any electrical charge, so choice D is also wrong. The correct choice is choice C. Choice C is the one which is correct. Electrostatic attraction between the charged particles. The charged particles are protons, or the positive ions, and the delocalized electrons. Aluminium is malleable and can be easily shaped to make saucepans used for cooking food. State 2 other properties of aluminium that make it suitable for saucepans used for cooking food. That aluminium can be used as saucepan. Number 1 is because it conducts electricity or it conducts heat. It can be used for that. So aluminium can be used for that because it conducts what? It's a good conductor of heat. It is a good conductor of heat. Number 2, it has got a high melting point. High melting. And it is used for cooking food, meaning it does not react with what? Does not react with food. Number 3 or number 4 that we can say, it resists corrosion. Aluminium is able to resist what? Corrosion, or what we refer to rusting. But the word rusting only refers to what? Refers only to iron. So aluminium can conduct heat. It's a good conductor of heat. It's got a high melting point. It does not react with food. It resists what? It resists corrosion. And we can also say it has got low density. It has got low density. So there are so many things that we can write there about what? About aluminium as a metal. Those are reasons why aluminium are used to make what? Saucepans, or what we call the spurias. The next year, magnesium is an alloy of aluminium and magnesium. Magnesium is an alloy of aluminium and magnesium. The diagram shows how the atoms are arranged in this alloy. So you can see atoms of magnesium and atoms of aluminium. The atoms of magnesium tends to be bigger than atoms of what? Of aluminium from the mixture, from the alloy. So they say, state what is meant by the term alloy. State what is meant by the term of alloy. Alloy is a mixture of two or more metals. That is what we call an alloy. An alloy is a mixture of two or more metals. Explain why magnesium is harder than aluminium. Explain why magnesium is harder than aluminium. Number 1, we say the regular lattice or regular arrangement is distorted. The regular lattice or the regular arrangement is distorted. The regular arrangement of aluminium and the regular arrangement of magnesium is distorted. Is that okay? Yeah. Why? Because we can say magnesium and aluminium have different sized atoms. Magnesium and aluminium have different sized atoms. So the regular lattice is distorted or disturbed. And then we say that magnesium and aluminium have different sized atoms. So we say it is not easy for them to do what? To slide over each other. They can now not slide. Metals can be beaten into shape, metals can be pulled into wire because of the regular arrangement of the particles. But now here we have got magnesium and aluminium, which are having different sized particles. So they cannot slide over each other. They cannot slide over each other. So this paper is out of 70 marks and it contains 8 questions. So I've done the 4 questions in this video. I will stop this one at this point and then I will do the other 4 remaining later. In case you have any question, kindly please leave it at the comment section. Thank you.